Okay, so in this video, we'll be discussing probability and statistics 2, which is for May-June 2024, paper 6-3. So let's start with question number 1. There's a random variable x with the distribution of this, and they want us to use a suitable approximating distribution to find the probability. Highlight the keyword approximating. Okay, so just to recall back, for binomial distribution, right, there are a few approximation you can make. From binomial, you can change it become normal in AS, but this is in A2, right? So binomial, basically, you can change it become Poisson distribution. And what's the condition here? The condition must be n greater than 50 and also np smaller than 5. Okay, so since they already give us the keyword, therefore we can directly change it become Poisson. So I'm having x originally, which is binomial distribution, and we are going to change it become Poisson, where Poisson is how to get the lambda in Poisson. Lambda is mean. So how to get the mean from binomial distribution? You are taking 4000 n times p. So this is your n in binomial distribution, and the p is 0.001, and you get the lambda equals to 4 in Poisson. Okay, then if I want to calculate the probability for 2 until 5, included the 2 but exclude the 5, then we have to use the Poisson formula now because we have changed it become Poisson distribution, right? So the general formula for Poisson distribution is x equals to r, and then you're having e negative lambda power r divided by r factorial. This is the general formula for Poisson distribution. Okay, so for x included the 2 less than 5, you have to start from x equals to 2. So for x equals to 2 is e negative lambda. So lambda power 2 divided by 2 factorial, followed by x equals to 3. So x equals to 3 means lambda power 3 divided by 3 factorial. X equal to 4 means lambda power 4 divided by 4 factorial. Okay, so when you simplify it using calculator, you'll get a long value of answer. So this is what we have. Then I want to correct it to 3 significant figure, and therefore you'll be having 0.537. Okay, then let's continue to part B. For part B, they are asking for this, justify your approximating distribution in this case. So they want us to justify how can we change binomial become Poisson. So like what I told you just now, because the condition here actually fulfill the condition of changing binomial become Poisson, right? So when n equals to 4000, it means that it already fulfilled the condition where n greater than 50. Then np is equals to 4 in our case. It also fulfilled the condition where np is smaller than 5. So these two basically is the reason that we allowed to change binomial become Poisson. Alright, so this is how we answer question number 2. The width, which is WCM of random sample 150 leaf, were measured, and then the sample mean of W was found to be 3.12. So they are giving you the keyword sample mean here, where this is basically x bar. So the x bar is 3.12. And now by using this sample, right, a 95% confidence interval of the population mean of width in the centimeter was found to be this one. So this is the confidence interval. Calculate an estimate of the population standard deviation. Right, so to get the population standard deviation, right, since the value that is provided in this question, they are talking about the confidence interval. So you can use any formula or any value here. Either you can use the lower limit for confidence interval or upper limit for the confidence interval to get the population standard deviation. Because population standard deviation is involved, okay, in forming the confidence interval just now. So just to recall back again, so what is the limit, upper and lower limit for the confidence interval? Basically it is x bar plus minus z, and then standard deviation over square root n. So the plus one will be the upper limit, the minus one will be the lower limit. And now if I want to apply it in my calculation for this question, I maybe want to use the lower limit. If you want, you can use upper limit. Both of them will give you the same answer. Alright, so if I use the lower limit, it will be x bar minus z sigma over square root n equals to lower limit 3.01. Okay, so x bar I have the value which is 3.12. It is provided just now, right? And then for the z here, because I don't know the z, therefore I need to find out the z. So the value of z basically depends on the confidence level that you have. So we are having 95% confidence interval, confidence level, so that means 0.95 is in the center. So there are two sides here which is symmetrical. Okay, so for these two sides, the area should be 0.025, so that the total area under the graph is a 1. And if I want to get the value of z, this is a value of z, I have to look at the area that z smaller than this particular value equals to 0.975. Because if you total these two areas together, it is 0.975, right? Okay, so you go to the normal distribution table. Maybe you can look for the shortcut table at the bottom. Alright, so is there any 0.975? So I think you can see very clearly. 0.975 is 1.96 for the z. Okay, so our z value here will be 1.96. Sigma, we don't know what's the value, so you just copy as sigma. Then the n here, sample size is basically 150. Then you let it equals to 3.01. Okay, and from here, if you slowly move all the number to one side and rephrase all your equation here, you'll get the value of sigma. Okay, so you try to press the calculator carefully. Don't make sure don't do careless mistake. And by right, I have to correct our sigma into 3 significant figure, which is 0.687. Okay, so this is how we solve the part A. Then let's have a look for part B. They want us to explain whether it is necessary to use the central limit theorem in part A. Okay, so you go back to the question and please have a look for the question here. Did they mention anything about the distribution of population? So you can see from here, they didn't mention anything about distribution of population. All right, but when you do the calculation, we are using basically the normal distribution formula, right? Okay, so that means we are using central limit theorem in this case. Okay, so you have to tell them that I'm using the central limit theorem. Okay, they ask why, or they say is it necessary. Okay, so yes, central limit theorem is needed. Because what is the reason? Because the population distribution is unknown. Question number. Okay, so question number 3. They are talking about the mass in kilogram for large and small bags. We are having large bags, we are having small bags of content, of cement, sorry, have independent distribution and both of them are normally distributed. Okay, so maybe for the large one, I label it as X, small one, I label it as Y. They want us to find the probability that the total mass of 5 randomly chosen large bag. So 5 randomly chosen large bag means X, 5X, okay, greater than the total mass of 10 randomly chosen small bag. So they are asking us to find the probability of 5X greater than 10Y. Okay, so for 5x greater than 10y, you cannot calculate the probability in this way. You have to move all the variable to one side. So that means you're having 5x minus 10y greater than 0. Okay, so before you can calculate this probability, I have to figure out what is the mean and also the variance and distribution for 5x minus 10y. Okay, so to get the mean for 5x minus 10y, you're having 5 times of mean x. What's the mean x here? 50, right? Okay, so 50 minus 10 times of the mean y. What's the mean y? 26. It was provided in the question just now, yeah? Okay, so the mean value here, it should be negative 10. How about for variance? Okay, so for variance, I'm having 5x minus 10y. When you take out the 5 from the variance, right, it is still a 5 here. There's no square because it is not 5 times of a large bag. You're having 5 different large bag. Therefore, the variance should be addition. That means variance x number 1 plus variance x number 2 plus variance x number 3 until x number 5. Therefore, it is multiplied by 5 but not 5 square. What's the variance of x that we have here? It is provided 2.4 just now. Okay, then minus. So for variance, there's no minus. You have to always change it become a plus. Okay, then 10 times of the variance y. So the same thing is, put in the variance y, you're having 1.8. When you total them together, you'll be having 30. Okay, and now since x is normally distributed, y is also normally distributed, so the linear combination of this kind of variable is still normally distributed. Alright, so you're having negative 10 and also 30. Okay, so once you know that this is normally distributed, you can continue to calculate your probability. So 5x minus 10y is normally distributed, so you have to change it become z. Okay, so you take this value, x value, minus the mean. So minus the mean means minus the negative 10 divided by standard deviation. That means you divide it by square root 30. Okay, so what is the value of z that I get from that? So the value of z I get from that is 1.826. Then take 1 minus the probability of z smaller than 1.826, because in table we can find out z smaller than 1.826 only, right? Okay, so you go to the table looking for 1.82. 1.82 is this one, and then you have to add 6. 6 is where? This is a 6. So that means you have to take 9656, add a 4 at the last digit. So 9656, if you add a 4 at the last digit here, you have 9660. Okay, so if you go back to your table again, so 0.9660, and after you simplify it, you will get the probability 0.034. So this is how we get the answer for part question number. Okay, so question number 4. In this question, you should not use an approximating distribution. So they are not going to change any distribution to become the other one, right? So they are talking about maybe a place or a city. There are 24% of voters supported the party, Today party. Then a student wishes to test. So you highlight the keyword test. Yeah? To support the party has decreased. Highlight the keyword decrease. This is the keyword to help us set up the alternative hypothesis. He chose a random sample of 25 voters, and after that, exactly 2 of them that says that he will vote the Today party. So 2 means the observed value, and you are going to use it to calculate the p-value later. Okay, so first they want you to test at 5% significance level whether the support for Today party has decreased. Alright, so this is a test to test on population proportion. So first, let us set up now an alternative hypothesis. They are talking about the population proportion, so it will use the p lah. Okay, so p is equals to 0.24. 24 is percent lah. So you change it become proportion. So it will be 0.24. Alternative hypothesis, you look at the keyword decrease. So you know that it should be smaller than 0.24. When we are running the test on population proportion, we need to use binomial distribution. The sample size is 25 for this case, and then the probability that we are using is 0.24. And now we have to calculate our p-value. So to calculate the p-value, okay, so you look at the 2. 2 is the observed value. Okay, then we have to find the probability for x smaller equals to 2 because alternative is smaller. So your rejection region basically will be on the left. So we are interested to calculate the probability on the left hand side of 2, which is smaller equals to 2. So for binomial distribution, you have to start from x equals to 0. So 25C0, 0.24 power 0, followed by 0.76. This is a Q, power 25. Okay, then x equals to 1, 25C1, 0.24 power 1, 0.76 power 24, and so on. Right, then 25C2, 0.24 power 2, 0.76 power the 23. Okay, so if you try to calculate the probability here, you are getting 0.0407. And this is what we call as p-value. Right? Okay. And after that, when we want to make any decision or conclusion about this test, yeah, we are going to compare p-value with the alpha, the significance level. So p-value is 0.0407. And if you try to compare, it is basically smaller than alpha, which is 0.05. Okay, so that means the area is smaller, sigma is larger. So the area, right, the Z or maybe the probability borderline, it still falls under the rejection region because the alpha here is the borderline, okay, or the reference area for us to decide whether is it rejection or acceptance region. So if let's say the area for p-value is still smaller than this, that means the whole area falls under rejection region, right? Okay, therefore we are going to reject the null hypothesis. Okay, so make a simple conclusion on this one. So there's sufficient evidence to show that the support for the party has decreased. So this is how we solve question number 5. There's a random variable x with this probability density function, okay, and the domain given will be the x defined will be from 0 until cert 2. So this is a function fx. Okay, they want us to show that a equals to 2. Okay, so first, to find out the constant a, right, you have to use the one basic concept where you integrate the whole function for your probability density function, it should be equals to 1. Okay, so let's start from here. I want to integrate. The limit is 0 until cert 2. Okay, for the function is ax minus x power 3 dx, and I let it equals to 1. Okay, so integrate this, you'll be having x squared over 2 minus x power 4 divided by 4, power plus 1, right, divided by the new power. So you want to substitute 2 and also 0 into your expression after integration. Okay, so cert 2 square, you get a 2. So you're having a. Cert 2 power 4, you're having 2 times 2, which is a 4. So 4 divided by 4, you have a 1. Okay, then minus, you are getting 0. After you substitute all the 0 here, it is equals to 1. And therefore, very easily, you can get the value a equals to 2. Okay, so this is how we get the proof. Right, we are using the concept where you integrate the whole limit for function fx and it is equals to 1. Okay, then let's continue to part B for this question. For part B, they want us to find the median of x. So let's say we assume median is m, yeah? Okay, so you need to know that for smallest value until median, right, if we integrate the function, the area that we get is 0.5. Because median is the center position for the whole function. So if you integrate from 0 until median, basically it consists of half of your whole area, which is 0.5. So this is the concept that you are using it here, right? And let's start with our question. To get the median in this question, I want to integrate from 0 until median. And my function is 2x minus x power 3. And I let it equals to 0.5. Okay? And let us integrate it. X integrate power 2 divided by new power. So I simplify 2 and the new power, I get x squared. Then for this one, I integrate, I get x power 4 divided by 4. Then substitute it with limit m and also 0. And it is equals to 0.5. So what do I get here? I get m squared minus 1 over 4 m power 4. If you substitute 0 here, everything will become 0, okay, equals to 0.5. And we are trying to solve this equation. To solve this in terms of m, right, I multiply whole equation with 4 because I want to get rid of the 4 as a denominator. Okay, so 0.5 times 4, I get a 2. Then eventually I get this one. Okay, all right. So this is basically the quadratic form equation in terms of m. Okay, so if you try to observe this, basically you can't factorize it. So what I want to do now is to solve for the m square, I need to use the quadratic formula, which is negative b plus minus b square minus 4ac divided by 2a. Okay, so from here, you'll get two values for m squared. The first one is should be a long value, 3.414213562. Another one will be m square equals to 0.585 blah blah blah. It's a very long value, okay? 585, 7864376. Then to get the m from m square, I have to take square root both sides. When I take square root both sides, I have to consider plus and minus sign. Okay, so if I consider plus and minus sign for this answer, correct to three significant figure, I get plus minus 1.85. And then for this second equation here, I got m equals to plus minus 0.765. Okay, and now you have to double check and see which is the answer that I should accept for as my median. So I'm having plus minus 1.85 and also plus minus 0.765. If I have a look for my diagram here, they actually define that the x defined is basically 0 until cert 2. That means all your value of x should be between 0 until cert 2. What's the value for cert 2? 1.414. Okay, then if you go back to your median, by right, your median answer, right, should be between 0 until 1.414 as well. So very obvious, this answer, right, is already out of our range, because 1.85 is already more than 1.414, and our maximum x should be 1.414 only. So median cannot be lies outside the x defined. Okay, so this whole set of answer I need to reject it, because in the definition also x is greater than 0, so the negative answer should be rejected as well. Then for this one again, the negative value definitely should be rejected, so we are not consider the negative value. So for positive 0.765, right, it lies between the value of x. Therefore, the correct median for this question should be 0.765, correct to three significant figure. Okay, then let's have a look for part C. Okay, so for part C, they want us to find the exact value of expected value of the x. So how to find the expected value? Exact value here tell us that you have to keep our answer in maybe surd form or pi form or exponential form, right? Okay, so to get the ex for a continuous random variable, you need to involve integration again. You have to multiply the x with the function before you can integrate them. Okay, so we will start this integration now. So to get the ex, okay, so I integrate from 0 until surd 2, multiply the x into the function. So what's my function again? 2x minus x power 3. Okay, so start the integration. Before you start the integration, you have to simplify first, or expand it first. Okay, so you're having two terms in x power n. Then only we start with the integration here. So 2x power 3 divided by 3, x power 4 divided by 4, and I'm having surd 2 over 0. Okay, so substitute your answer. So I'm having 2 over 3, surd 2 power 3. So surd 2 power 3, surd 2 power 3. Then I'm having 1 over 4, surd 2 power 4. Did I do any careless mistake? Yeah, I think I did a careless mistake here, right? After the integration, sorry for that. This is x power 4. After integration, I should get x power 5, not x power 4. Okay, so let's continue from here. Again, substitute surd 2 into the x power 3, you have surd 2 power 3. Copy the constant 1 over 5, I'm having surd 2 power 5. Okay, then substitute 0 here, the whole thing is a 0. Alright, so when I simplify this particular term here, I will have surd 2 power 3 means 2 surd 2. So 2 surd 2, 2 times 2 is a 4, 4 over 3 surd 2. Then surd 2 power 5 means that you're having 2 times 2 times surd 2, so which is 4, 4 over 5 surd 2. Okay, so you can treat the surd 2 as apple, so you're basically having 4 over 3 apple minus 4 over 5 apples. So how many apples do you have here? You'll be 8 over 15 apples. Okay, yeah, so this is how we get the expected value for the function. Okay, so for question number 6 now, the number of green sweets in 200 randomly chosen packets of fructose are summarized in the table. So we are having the number of green sweets and also the number of packets. So you should know that number of packet means the frequency appear, so it should be the F. And then for the number of green sweet, it will be the value of the X. Okay, they want us to calculate the unbiased estimate for population mean. Okay, and also show that the unbiased estimate for the population variance is this one. Alright, so how can we calculate the mean and also the variance first? So before that, if you have a look for the estimation formula, right? The estimated mean should be using the formula summation fx over summation of f. And for the variance, it should be 1 over summation f minus 1, which is 1 over n minus 1. And then you're having summation of fx squared minus summation of fx square the whole thing divided by the n which is summation of f. Okay, so in case you can't remember, this is also provided in the formula booklet, just that you have to change the n become summation of f. Alright. Okay, so before that, I prefer to calculate out my summation of fx and summation of x square first. So x is 0, right, for the first one. Then 32 is a frequency. So you are taking f multiplied with the frequency. X multiplied with the frequency. And you continue for the rest of the bar. So 1 multiplied with 50, 2 multiplied with 97, 3 multiplied with 21, and total them up. You get 307. After that, I also calculate summation of fx square first. This one means that you have to square your x, then only you multiply with the frequency. So I'm having 30, then 0 square, plus 50, then 1 square, and so on. So I'm getting 627. Then after I get all these important value ready, then only I start the calculation. So what's the mean here? The estimated unbiased estimated for the population mean will be 307 divided by your sample size. So what's the sample size here? The total of frequency. The total of frequency, they did tell you that it is 200. This one. Okay, if not, you can try to add all the frequency here together also, and you can see that it is also 200. Alright, so you take 307 divided by 200. Let's see what do we get. Okay, so we get 1.535 as the unbiased estimated value for the mean. Okay, then after that I want to calculate the unbiased estimated value for variance. So 1 over summation of f minus 1, so 199. What's the summation of fx squared? So you get the value just now. If you don't do careless mistake, yeah, it should be 627 minus summation x squared, so 307 squared divided by the total frequency 200. So if you correct your answer to 3 significant figure, right? So by right, you should get what they want you to show, which is 0.783. So this is the mean and this is the variance. Alright, okay, so let's continue to part number 2. For part number 2, the manufacturer says that the mean number of green pack is this one, 1.65. And NG believe that the true mean should be less than 1.65. Highlight the keyword less than. If we are running the test, right, the word less than will be your keyword to set up the alternative hypothesis. So she used the result from the 200 randomly chosen packet to test the manufacturer's claim, state the suitable noun and alternative hypothesis for the test. Okay, so they are going to test on the population mean. So the manufacturers claim that the mean is 1.65. But Angie feels that it should be less than that, right? So the mu should be less than 1.65. This will be your alternative hypothesis. So this is part B. Then continue to the next part, which is part C. They want to show that the results of Angie's test is significant at 5% level, but not at the 1% level. Okay, so talking about 5% level and 1% level, right? Basically, it means that if you run the test, okay, it will be significant at 1%, but it will not be significant at another percent. So let's say this is 1% level, and the bigger one is the 5% level. And they want you to prove that the test, right, is significant. Significance means that more than 1%, but less than 5%. That means if let's say it is in acceptance region, means acceptance region is 1%, means it is significant. Okay, so maybe before that we just try to run out the test first. If I want to run the test, right, there are two ways that you can do it. Alright, so because this is normally distributed, so maybe for us, we are using the critical value to compare. So you can have a look here. So the green color one is 0.05 and the red color one is 0.01. Okay, I want to know what is the exact value for the red color one, the critical value. So for the critical value, okay, for 1% test, if you have a look for the critical value here, basically it is looking for 0.99. So you're having 2.326. So this is negative 2.326 because it is at negative side. And how about for the green color area, which is 0.05 or 5% level? So the Z at 5% level, I'm going to look at 0.95. So if you look at 0.95, you will get 1.645. So the green color Z is negative 1.645. And now for the test that I try to carry out, I want to get the test statistics so that I can compare with the critical value. So what's the formula for test statistic here? Okay, so the test statistic formula is you are using x bar minus the population mean divided by standard deviation over square root n. What is your x bar? So our sample mean just now is 1 point. You can get it from the previous part just now. So your sample mean just now is 1.535. Okay, so I can use 1.535 minus the population mean that they want us to calculate, which is this one, 1.65. Okay, then divided by the population standard deviation, it should be square root of 0.783 because we have estimated the value just now, right, which is 0.783 divided by the sample size 200. And from here, your test statistics, by right, you'll get the value negative 1.838. Okay, and now if you try to compare this 1.838 with the two critical value here, you realize that the 1.838 falls between these two values, negative 2.326 and also negative 1.645. That means if I observe the test by using the 1% significance level, it will be accept the, do not reject the null hypothesis. But if you run the test at 5% significance level, you realize that it is under rejection area where you reject the null hypothesis. So that's the meaning of what they want us to show here. Show that the result of his test is significant at 5, but not at the 1% level. Okay, so you compare it with the critical value. So I'm having negative 2.326. Okay, then negative 1.838 and also negative 1.645. Okay, so you reject the null hypothesis at 5% significance level, but not 1%. Okay, so that means what? That means the test is significant at 5%. Alright, so this is how we get the answer for part C. And let's continue to part D. It is given that he has made a type 1 error. So explain how this shows the significance level that he used is not in 1%. Okay, so let's write out or recall back the definition for type 1 error first. So Taiwan error means what? You reject the null hypothesis when your null hypothesis is true. And Taiwan error can be made only in the test where you reject your null hypothesis. Okay, so in this test, in this question, yeah, you realize that, okay, null hypothesis is rejected at 5%, but not at the 1%, right? Therefore, at the 1% significant test, yeah, basically you won't get the Taiwan error, because for 1% significance test, you are accepting the null hypothesis, which is not reject. So Taiwan error cannot be made in 1% test. Okay, because the null hypothesis is not rejected in the 1% test. So this is basically how we explain. Okay, so this is how we solve question number 6. Okay, so let's have a look for question number 7. So we have two distribution x and y, and both of them are Poisson distributed. They want to get the probability for x plus y smaller than 4. Okay, so first of all, you need to find what's the distribution for x plus y first. Okay, so x is Poisson, y is also Poisson. Therefore, the linear combination x plus y is also Poisson distributed. And then to get the new lambda for x plus y, you have to add the two lambda together, where you will get 4.1. Okay, then after that, you can continue with the calculation for the probability x plus y smaller than 4. Okay, so Poisson distribution is discrete random variable. So when you want to calculate the probability, it should be integer. So you can start from x plus y equals to 1, x plus y equals to 0, x plus y equals to 1, x plus y equals to 2, and so on. Okay, so for x plus y equals to 1, the formula is e power negative lambda. Oh, maybe let us recall again. If I want to calculate the probability for x equals to r, what is the formula? E negative lambda, lambda power r divided by r factorial. Okay, so for x plus y equals to 0, I'm having e negative lambda, lambda power 0 divided by 0 factorial is a 1. Okay, so x plus y equals to 1, it is lambda power 1 divided by 1, so it is the lambda. Okay, then x plus y equals to 2, so you're having x lambda power 2 divided by 2 factorial. X plus y equals to 3, you're having lambda power 3 divided by 3 factorial, and you should stop here. Because in our calculation here, they are not asking for equals to 4. The smaller than 4 means not include the 4. So that's why this is how you set up the question. Then you're having 0.4141815,415. Okay, so end up you should be having 0.414 here. Correct to 3 significant figure. Okay, so let's have a look for part number B. For part B, they want to find the probability that x equals to 2 given that, highlight the keyword given that. So this is a conditional probability. Okay, so what is the definition for the conditional probability or the formula? So given that A happened, they want you to find the probability that B happened. Okay, so the general symbol for conditional probability is you have a slash here. Given that A happened first, right? So the A is right up on the right hand side of the slash, then B will be on the left. And to define this and get the answer for this conditional probability, the general formula is A intersect of B intersect with B divided by the probability of A. So same thing happened for this question in our part B. Okay, so given that means slash, then you already know that x plus 4 smaller than x plus y smaller than 4, and you want to find the probability for x equals to 2. So what is the formula? General formula is x equals to 2 intersect with x plus y smaller than 4 divided by the probability of x plus y smaller than 4. Okay, so for the probability for x plus y smaller than 4, basically we have get it from the answer just now, right, in part number 1. Okay, so you can directly substitute the long answer into this part first, into the denominator first. Okay, then how about for this one? So for this one, they are asking for x equals to 2, but at the same time, x plus y must be smaller than 4. That means there are two possible cases here. When x equals to 2, my y equals to 1. So from here, you get x plus 1 equals to 3. So you cannot have x plus. So what is the possible cases for this event, the intersection point here, the intersection part here? I can also have x equals to 2, then y equals to 0. So that 2 plus 0 is 2, which is also smaller than 4. So some students ask, can I have x equals to 2, then y equals to 2 or not? In our calculation, so cannot, because 2 plus 2, you get a 4, equals to 4. But in our calculation here, it should be smaller than 4. Then y cannot be negative. X can be only the 2. So basically, these are the two possible outcomes that I have for the intersection. X equals to 2 and x plus y smaller than 4. Okay, how can I calculate the probability for x equals to 2 and also y equals to 1? So you have to calculate it by using the Poisson separately. So focus on the x first. The lambda for the x is negative, is 1.9. So x equals to 2 means that e negative lambda power 2 divided by 2 factorial. This is for x equals to 2. Multiply with y equals to 1. So the lambda for y is 2.2, right? So e negative lambda power 1 divided by 1 factorial. This is for the first case. Then plus. Second case is e negative 1.9. This is x equals to 2. So lambda power 2 divided by 2 factorial. Multiply with y equals to 0. Means e negative lambda power 0 divided by 0 factorial. And you have to, of course, divide this whole thing by x plus y smaller than 4. Okay, so when you simplify this whole fraction here, again, you will definitely get a very long value. Okay, so correct it to 3 significant figure. Your answer should be 0.231. Right, so this is what we get for part B. Then let's continue to part C. There's a random sample of 60 chosen pair of xy, and basically they calculate the x plus y. Sample mean for these 60 values is found. Okay, so you're having x plus y here, and then they get the sample mean for the 60 pair of values. So find the probability of the sample mean x plus y is less than 4.0. Okay, they're asking for sample mean is less than 4.0. So the keyword is sample mean. So they are talking about sampling distribution for this case. All right. Okay, so to get the sampling distribution, if your population, maybe I directly write it here easier, because I know that for every single x plus y, it is Poisson distributed with the mean 4.1. And now I want to get the sample mean. Okay, so to get the sample mean, what is the distribution for the sample mean for x plus y? So first thing, you have to look at the sample size here. Sample size is larger than 30, right? It is a large sample size. Therefore, according to central limit theorem, or maybe according to central limit theorem, the sample mean will be approximately normal distributed. And how can I get the mean? Okay, so for the sample mean, so the mean of the sample mean will be equals to the population mean. So that means it will be 4.1 for this case. Okay, and after that, how can I get the variance for the sample mean? Variance of the sample mean x plus y, if you want to write out. So the variance for the sample mean will be the population variance divided by the sample size. Population variance is 4.1. Also because it is Poisson, so the variance for Poisson is still 4.1, which is also still the variance, okay, for population, then divided by the sample size, which is 60. Okay, so this is how we change or we get the sample mean distribution. Okay, so again, the population mean, sorry, the sample mean, expected value for the sample mean will be equals to the population mean. The expected value, okay, for variance, sorry, the variance of the sample mean of x plus y, it will be taking population variance divided by the sample size. And now, because I know that sample mean is normally distributed, therefore you have to change it become z before you can calculate the probability. Originally, this is Poisson, and you have changed it become normal distribution, right? So from discrete to continuous, by right, you have to do continuity correction. Okay, so in our syllabus, because they're aware that this is a sample mean, when you want to divide or you do the continuity correction, the value of continuity correction is very small until you can omit it. All right. So in the marking scheme, if you read through the marking scheme clearly, basically they accept both answers. One answer is without continuity correction. Another one is with the continuity correction. Okay, so of course I will choose an easier one where we don't do the continuity correction. By right it should be, but because of the value is too small until you can omit it, so you can still, you actually can try to ignore the continuity correction in this case, right? So how can I get the z? So to get the z, I have to take the x minus the mean. So minus the mean. Mean is 4.1 divided by the standard deviation over square root n. So what's the standard deviation here? Wait, let me draw it nicer. Okay, so the standard deviation is square root 4.1 divided by square root n is square root 60. Okay, then after that you get the value of z correct to 3 decimal place, it will be negative 0.383. To get this particular probability here, you have to take 1 minus 0.383. So you go for the table, looking for 0.3838 means this one, and also the 3. You have to take 6480 plus 11. So you're having 6491. Okay, then in our calculation here, you have to take 1 minus 0.6491. And hence you get this answer 3509, and of course I want to correct it to 3 significant figure. Okay, so this is how we find out the probability that involve the sample mean for x plus y. Okay, so this is the last question for this paper. Thank you very much for watching the